All right, so we're going to try and do this for 4, 5. And the first problem you're going to see, you're given the graph. Okay, so you have f of x here in green and g of x here in orange. Okay, and so we're going to deal with some inequalities. And in the first inequality, they're going to ask, when is g of x greater than or equal to f of x? Okay, so we want to know, when is the orange line greater than the green function? Okay, so you want to think, where are the orange values greater than the green values? Okay, so on this graph, the green values are greater than the orange values right here. They're above them on the graph, so we want to use them. Again, don't forget that g of x is the y values on the g function and f of x is the y values on the f function. So the y values are greater on the g of x function when it's above the parabola. So we're going to then use the x values to go from there. Okay, so this isn't super clear. This is the point -2.8. I kind of made it a little close together. So it's going to go from -2 all the way to 1. And we're going to use square brackets because we have that greater than or equal to sign. So we don't have to worry about, hey, is it open or is it closed? Okay, if they were to ask you in set notation, you're going to use the squiggly bracket x such that -2 is less than or equal to x is less than or equal to 1. So we talked about how to convert them from one to the other when we did inequalities way back, I believe in chapter 1. Okay, so they're going to give you a second version. They're going to ask, when is f of x greater than g of x? Okay, so when is the f function greater than the g function? Okay, on this graph, the f function is greater than the g function right here. So the f function has greater y values right there, and it also has greater y values right here. So we need to have two different pieces of interval notation in order to represent that. Okay, so we're going to do the left side, which is -infinity to -2. Remember to use the x values. And we're dealing with a greater than sign, so no square brackets, union, and then we're going to start at 1 and go all the way to infinity. So you're going to have a couple of those to deal with where you read the graph. Okay, then you're going to get quite a few where it says solve x squared minus 4x is greater than 0. So they're going to give you the algebraic expression and tell you, when is it greater than 0? Okay, so I like to do some setup before I'm going to use the calculator to help me out to do it. Okay, so the first thing I'm going to do is factor it. So I get x minus 4 is greater than or equal to 0, so that I can find out where the x-intercepts are. So my x-intercepts here are 0 and +4. And when I have those x-intercepts, it's going to break up my inequality. So I can write an interval that are my possibilities for this answer. So I'm going to write an interval where 0 and 4 are the ones that are going to break up my inequality. So I'm going to write -infinity to 0. That's my first break. I'm going to write 0 to 4. And I'm going to write 4 to infinity. So we go in numerical order. So we're not going to have 3 answers. We're going to either have 1 or 2 of them as our answer. And so what I'm going to do next is I'm going to put it in my graphing calculator. Okay, so here's my graphing calculator. It looks like we can see it okay. And I'm going to type in x squared minus 4x. And remember, if you have to hit zoom 6 for your standard window, okay? And we're looking for when is it greater than or equal to 0? So we're going to use the x-axis as our dividing line. So when is it greater than or equal to 0? Well, it's greater than or equal to 0 from negative infinity to 0. That's half of it. And then it's above the x-axis again from 0 to, or sorry, from 4 to infinity. So we have two of those pieces. So we have this one and we have this one. Okay. Two other things we need to consider when writing our answer. One, what does the inequality sign show? If it has an equal to bar, then we need to put a bracket on it. And number two, if it has more than one inequality, we need to put a U in between. So my answer here is going to be negative infinity to 0, union 4 to infinity. So I have two different intervals as my answer, and the union is going to connect them together. Okay, so we're going to do another one. X squared plus x is greater than 12. Okay, now we're going to do the same thing, but first we have to set it equal to 0 or make sure everything is moved to one side. So I'm going to subtract 12. Okay, so now that I've subtracted 12, again, I'm going to factor so that I can find the x-intercepts. So I get x plus 4 and x minus 3. Okay, so I get x-intercepts of negative 4 and 3. Okay, if I write them in numerical order, then again, it's really easy for me to write the possible intervals. So I either get negative infinity to negative 4, negative 4 to 3, and 3 to infinity. Now I write these just so that it's easier for us to understand what we're looking for. Okay, so now I'm going to go back to my calculator and I'm going to type in this one. So I want x squared plus x minus 12. Oops, forgot to put it in y equals. Happens to all of us. X squared plus x minus 12. So again, I want to look, this one asks for greater than or equal to. So I want everything above the line. So everything above the line. So I'm going to have the first interval from negative infinity to negative 4 and from 3 to infinity. I don't have to read the x-intercept here. I don't have to go and then use the calc function to find where the x-intercepts are. I already have them written out as all the possibilities. Okay, so I'm going to be able to use the first one and the last one. Again, we're going to go back and double check what's the sign. And because there's two of them, we're going to put a union sign. Okay. All right, so there's one more possibility that could happen. And unfortunately, we didn't do the last one. Okay, we'll get into one that might be less than, all right, in a little bit. So this one's already set equal to 0. And I'm going to just type this one into the calculator. All right, so let me make sure I do it right this time. Oops, I went into the plot. Okay, so let's do x squared minus x plus 1. Okay, and I want to know, when is it below the x-axis? When is it less than 0? Well, look, if I were to block it out and say, hey, when is it less than 0? Well, it's not less than 0. So we don't have any part of the interval. So when we don't have anything part of the set, we're going to put no real solutions. There was no way to factor it in the beginning. we would have had to either do completing the square or quadratic formula. Okay. So the last problem in this lesson asks us to go back and kind of do what we did in the first section. We have two functions. The first one is x squared minus 1, and the second one is 3x plus 3. And it's going to ask us to do a variety of things with it. Okay, so the first couple are going to be a little bit of a review, but they're a little bit harder than what we did in 4.1. So the first thing we're going to do is, when is f of x equal to 0? Okay, so we're going to set the function that f of x is, and we're going to set it equal to 0. So x squared minus 1 equals 0. And you can factor it or solve for x squared either way. If I factor it, then I remember I get x plus 1, x minus 1. And so I get x equals plus minus 1. Okay. So B asks, when is g of x equal to 0? Okay. So I'm going to get, when is 3x plus 3 equal to 0? So 3x equals negative 3, and x equals negative 1. So pretty easy. So on C, they're going to ask me what happens when we set the functions equal to each other. So this time I have x squared minus 1 equals 3x plus 3. I'm going to still have an x squared in my answer. So the best thing to do is to make all of the terms move to the left side. So I'm going to subtract 3x, and I'm going to subtract 3 to get negative 4. And then I'm going to factor this one. So I get x minus 4, and I get x plus 1. So x equals positive 4 and negative 1. Okay. So now what they're going to ask us to do is to take the three things that we just did in A, B, and C and set them as an inequality. So remember that you can put the inequality in x squared minus 1 is greater than 0. So you could put the function in. But remember here in part A, we got plus minus 1. And on the other side, when we did those numbers, we said, hey, we factored on the x-intercepts are plus minus 1. And we then looked at, we're going to look at it on a calculator. Okay, so let's put x squared minus 1 in the calculator. And we want, when is it greater than 0? Okay, so most of it is greater than 0, but if we look again, there's a tiny part that's less than, and that part's between negative 1 and 1. Okay, so you could write out the whole inequality set like we did on the other side, or after you've done enough problems, you might realize that we get negative infinity to negative 1, and then we get 1 to infinity. So at some point, it does get a little bit easier. Okay, so let's do E. So we get, when is g of x less than or equal to 0? Okay, up here, we found out that we get negative 1. So we're looking at negative 1. Okay, so this one's a little bit less complicated than the other side. This one can give me negative infinity to negative 1, or I'm going to get the answer negative 1 to infinity. One of the two is going to be my answer. So let me type this in. We didn't see one like this. So 3x plus 3 goes into your calculator. And I'm going to graph it. And here, I'm going to look for what is less than the line. So what's below the line? Okay, so it's definitely negative infinity to -1. Okay, so it's not this one, but this one. So that's my answer here. Now on F, it says f of x is greater than g of x. Oh, and one correction on E is look at the sign. I have less than or equal to. So the actual answer is negative infinity to -1 with a square bracket. So that's the first time I think we encountered a square bracket. Let's double check on the other side. The only other square bracket was the no real solution one. So do be careful with that. Okay, so F is going to go back to this one right here, where we have 4 and -1 as the intervals that are going to cause the issue. Or sorry, the x-intercepts. So we're going to type in this piece right here. So x squared minus 3x minus 4. X squared minus 3x minus 4. And I'm looking, when is it greater than or equal to? So you might notice that a lot of these greater than or equal to's are all 2 parts. And for the most part, that's the case. So they're going to be the 2 parts. Okay, so again, we're going to break it up at -1 and 4. So this one is negative infinity to -1 union. It picks back up at 4 to infinity. Okay, one last problem on this one. This one's kind of a curveball. When is f of x greater than or equal to 1? Okay, everything else was 0. So I'm going to put x squared minus 1 is greater than or equal to 1. So I'm going to have to make it equal to 0. So x squared minus 2 is greater than or equal to 0. So I can type that into my calculator, but it's going to give me a decimal for the answers in terms of the roots. So if I were to make x squared minus 2 equal to 0 and solve for the roots, then I could try and find the actual roots here. So x squared equals 2, and the square root, don't forget, gives me plus minus the square root of 2. So my roots that I'm going to use to split it apart is going to involve plus minus the square root of 2. So let me type this one in, just for those of you that are visual. X squared minus 2. We're going to do greater than or equal to. Okay, so everything above the line. So I'm going to get that 2-part inequality again. And do be careful here because I have that greater than or equal to symbol. So my answer here is going to be negative infinity to negative square root 2. So it is going to be really picky on my math lab. Union, hard bracket, 2, square root of 2 to infinity. Okay, so if you're having any trouble understanding the notes or any trouble with anything else before class, do let me know. We're going to take questions right away starting at the beginning of class on Monday.